All right, so we can look at some problems where we're going to solve a quadratic equation using the quadratic formula. So keep in mind, it's important that you follow the directions. The directions said use the quadratic formula. So whenever you have a quadratic equation that is in standard form, ax squared plus bx plus c equals 0, and it's important in the process that you make sure that you have 0 on this side, then the solutions to any quadratic equation can be found by using the quadratic formula. And the quadratic formula says I take the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so once you find your values of a, b, and c, then you're going to substitute those into the formula. All right, so there's the formula. And so let's look at an example. So number one, we have 3x squared minus 11x minus 4 equal 0. And so notice that this is in standard form. I have this quadratic equation in standard form, and it's in descending order. So putting in descending order helps, so that way you don't make a mistake, because the a has to be the coefficient of x squared. It has to be the coefficient of your second degree term. So a in this case is 3. B is the coefficient of x, so make sure that you write the sign correctly. Signs are important. So that's a negative 11. And C is your constant, which is negative 4. And then once you find A, B, and C, it's just a matter of you taking these values and substituting it into the formula. All right, so we get x equal the opposite of B. So you read this as the opposite of B. So if b is a negative 11, the opposite of negative 11 is a positive 11. Plus or minus the square root of b, which is negative 11. Notice I'm putting that in parentheses, squared. Now keep in mind that b squared, so whatever this number is, it's going to be positive or 0. It can never be negative. B squared can never be negative. Minus 4 times a is 3, times c, which is negative 4. All of this, notice from here to here, is being divided by 2 times a, and a is 3. So here's your first step. So the first step is to take these values of a, b, and c and substitute it into the formula. Now the next step is to simplify the radicand. And in the quadratic formula, whenever you have a quadratic equation, this radicand is your discriminant. So it will tell you, one of the things it does, it tells you how many solutions you have and what type. But that's not important in this case, because you're just taking these values and substituting, right? So all you're doing. Okay, so we get 11 plus or minus the square root of negative 11 times itself is a positive 121. So notice it's positive. Okay, negative times a positive times a negative is a positive, right? 4 times 3 is 12, and 12 times 4 is 48. If you need to use your calculator, use your calculator. All of this is being divided by 6. So then we get 11 plus or minus the square root of, still simplifying the radicand, of 121 plus 48 is 169, all divided by 6. Now, we know that 169 is a perfect square, so the square root of 169 is 13. So if you remember, always use your calculator at this point. See if I can simplify the square root of 169. And when I use a calculator, basically the calculator, the way I'm doing it, basically I'm just determining if 169 is a perfect square. So you can say square root, oops, sorry. So let's see, square root. All right, let me get the square root. Second square root, all right, square root 169 equal, and I get 13. So 169 is a perfect square. So the square root of 169 is 13, so we're going to say 11 plus or minus 13 divided by 6. All right. So notice though that since 169 is a perfect square, and 11, 13, and 6 are all rational numbers, I'm going to end up with rational solutions. All right, now so since I'm going to end up with rational solutions, the way you want to write the answers is this way. So you're going to say 11, now remember, when you do that plus or minus, you're actually looking at two separate solutions. So you say 11 plus 13 divided by 6, like this, and then 11 minus 13 divided by 6. 11 plus 13 is 24, so you get 24 divided by 6. 11 minus 13 is a negative 2 divided by 6. And so simplify this further, because you all know that 24 divided by 6 is 4. So there's one of your solutions. So one of my solutions is 4, which is a rational number. 4 is a rational number. The other one, if I reduce, is negative 1/3, which is also a rational number. So those are your solutions. Okay, 4 and negative 1/3. All right, so if you take 4 and negative 1/3 and you substitute into the original problem, this side will equal 0. So that is solving the quadratic equation using the quadratic formula. So those are your steps. And it helps to determine whether you have rational solutions or irrational solutions or imaginary. So these were rational. All right, so that was number 1. Okay, let's look at number 2. Number 2, we have this problem for number 2. So we have, let's see, number 2 is y squared minus 8y minus 14 equals 0. All right, so this time my variable is y. And notice that 0 is already on this side. It's in descending order. So let's determine what A, B, and C are. So it helps to determine A, B, and C and actually write it out. So some students will write this out. A is a coefficient of y squared, the coefficient of the second degree term, which is 1. B is a coefficient of your first degree term, which is negative 8. And C is your constant, which is negative 14. And so remember, your formula is the opposite of B, plus and minus the square root of B squared, minus 4AC, all divided by 2A. All right, so the opposite of B. So B is a negative 8. The opposite of negative 8 is a positive 8. So I get y equal 8 plus and minus the square root of negative 8 squared, so B squared, no parentheses. This should always be, this should never be negative. It will either be positive or 0. Minus 4 times A times C, all divided by 2 times A, which is 1. All right, so at this point, we're going to go ahead and simplify the radicand. So I get 8 plus and minus the square root of negative 8 times itself is 64. So notice it's positive. A negative times a positive times a negative is a positive. 4 times 1 times 14. Use your calculator if you have to. 4 times 14. So 4 times 14 equals 56. All divided by 2. 2 times 1 is 2. So then simplifying this further, see all the steps you're going to do. So I get 8 plus or minus the square root of 64 plus 56. So 64 plus 56 gives us 120. All divided by 2. All right, so that's where I'm at. Now, don't leave your answer like this, because you can simplify this in several ways. All right, so remember, you got to simplify. First of all, let's look at the square root of 120. Square root of 120. The square root of 120 can be simplified because there is a perfect square other than 1 that goes into 120, and you want to use the largest. So, in fact, it's 4, because watch. So, 120 divided by 4, remember 4 is a perfect square, equal 30. So 4 times 30 is 120. And notice I cannot simplify that there's no other perfect square that goes into 30 other than 1, so 4 is the largest. So I'm going to rewrite this as the square root of 4 times the square root of 30, and the square root of 4 is 2, so you get 2 square root of 30. So that goes here. All right, so I get 8 plus or minus 2 square root of 30 divided by 2. Now you can simplify this further, because you see this, I'm going to rewrite this over. You see I have 8, 2, and 2. Those are all divisible by 2. So 8 divided by 2 is 4, 2 divided by 2 is 1, and then 2 divided by 2 is 1. And then this, anything divided by 1 is just a numerator. So then this becomes 4 plus or minus the square root of 30. And there's your answer. So those are your solutions. Notice, though, that remember in number 1, we had that 169 was a perfect square, and so 11, 13, and 6 were all rational numbers. So you're going to get rational solutions. Here, the square root of 30 is irrational, so you're going to end up with irrational solutions. And so notice that your solutions are irrational numbers. Now, one other thing, if this is multiple choice, you could have seen it written like this. You could have seen 4 plus the square root of 30, comma, 4 minus the square root of 30. So just other ways of writing the solutions. You can write it in compact form, or you can write them separately. All right, so that was number 2. Number 2, we ended up with irrational solutions as our solutions. Notice through the process we had to simplify. So remember all the things you have to do. All right, number 3. In number 3, we have x squared equal negative 7 minus 5x. All right, so this is not in this is not in standard form, so it's going to put this in standard form, so because you need 0 on that other side. So I'm going to get x squared, I'm going to put in descending order, so when I bring the negative 5x term over, I get positive 5x, and then negative 7, when I bring that over, I get positive 7. And so now a is the coefficient of x squared, so that's 1. B is the coefficient of x, so that's 5. And c is your constant, so that's 7. And your formula is the opposite of b, plus or minus the square root of b squared, minus 4ac, all divided by 2a. And notice b squared minus 4ac is under that radical symbol, so make sure it's under here. Okay, let's substitute now. So I get x equal, your variable is x, so x equal the opposite of b. Well, b is 5, the opposite of 5 is a negative 5, plus or minus the square root of b, which is 5. Notice I put that in parentheses, minus, and then 5 squared, minus 4 times a, which is 1, times c, which is 7, all divided by 2 times a, and a is 1. Simplifying the radicand, I get negative 5, plus or minus the square root of 5 squared is 25. A negative 4 times 1 times 7 is a negative 28, all divided by 2. So I get negative 5 plus or minus the square root of, all right, now 25 minus 28 is a negative 3, all divided by 2. All right, now remember, the square root of a negative 3 is not a real number. So what I'm going to end up with here are imaginary solutions. That's what I end up with, imaginary solutions. You got to remember that the square root of a negative 1 is defined to be I. Square root of negative 1 is defined to be I. So the square root of a negative 3, I can write as the square root of a negative 1 times the square root of 3. And the square root of a negative 1 is I, so I get I square root of 3. And we tend to put the I in front. Now you can put the I in the back, just make sure it doesn't look like it's under the square root. So that's why we put it in front. All right, so this becomes negative 5 plus or minus I square root of 3 divided by 2. And make sure that negative 5 is, that negative is with the 5. Don't put it out in front. And I cannot simplify anything, so that's it. And I cannot simplify the square root of 3. See, in number 2, I was able to simplify the square root of 120 because that was a perfect square other than 1 that went into 120. Here, the only perfect square that goes into 3 is 1. So that's it. You're done. Now, you can leave it like this in compact form, or you can write it in 2 separate solutions. You can say negative 5 plus I square root of 3 divided by 2, comma, negative 5 minus I square root of 3 divided by 2. All right. And sometimes you'll see this as well. Sometimes you'll see how I wrote it as one fraction, a numerator, a denominator? Sometimes they'll write this as 2 separate fractions. So they'll take the first term divided by the denominator and the second term divided by the denominator. So sometimes you'll see this negative 5 halves plus or minus I square root of 3 divided by 2. So those are all different ways of writing the solutions. All right. Okay, so that was number 3. So number 3, we ended up with imaginary solutions. So don't forget that the square root of a negative 1 is defined to be I. All right, so that's number 3. Okay, let's look at number 4. So number 4, we have this problem. All right, so let's see. We have this. All right, we have 5x squared equal negative 10x minus 1. All right, so let's put this in standard form. All right, so in standard form, I get 5x squared plus 10x plus 1 equals 0. All right, so be careful. Make sure you write this correctly. So A is 5, coefficient of x squared. B is coefficient of x, which is 10, and C is your constant, which is 1. So we're going to substitute that into the formula, into quadratic formula, b squared minus 4ac. All of that is being divided by 2a. All right, so the opposite of b. So b is 10, then the opposite of 10 is a negative 10. Plus or minus the square root of b, which is 10, notice parentheses, you're going to square that also, minus 4 times a is 5, times c, which is 1. All of that's being divided by 2 times a, which is 5. So I get negative 10 plus or minus the square root of 10 squared is 100. A negative 4 times 5 times 1 is a negative 20, all divided by 10. 2 times 5 is 10. So this becomes negative 10 plus or minus the square root of 100 minus 20 is 80, all divided by 10. And now let's talk about the square root of 180. So the square root of 180, square root of 80. So I can simplify the square root of 80. So at this point, you want to simplify if possible. So I can simplify the square root of 80. The largest perfect square that goes into 80. So be careful. It's not, you may say 4. So let's look at this. 80 divided by 4 is 20, right? So 4 times 20 is 80. But look at that 20. What other perfect square goes into 20 besides 1? Well, 4 again. So 4 times 4 is 16. So the largest perfect square that goes into 80 is 16. So you say square root of 16, and then times the square root of, and then 80 divided by 16 will be 5, right? Okay? And so I get 4 square root of 5. So that goes here. So I get negative 10 plus or minus 4 square root of 5 divided by 10. All right? So simplify as much as possible. Now, I can simplify this further because I'm going to go ahead and rewrite this over just to show you. So notice that this negative 10, this 4, and this 10, they're all divisible by 4, right? They're all divisible by 2, excuse me. So negative 10 divided by 2 is a negative 5. 4 divided by 2 is 2. 10 divided by 2 is 5. So this right here, you can write your answer now as negative 5 plus or minus 2 square root of 5 divided by 5. All right? And if you want to write it as two separate solutions, you can. You would say negative 5 plus 2 square root of 5 divided by 5, and then negative 5 minus 2 square root of 5 divided by 5. You can write this as two separate fractions. So watch. This becomes negative 5 divided by 5, right? Plus or minus 2 square root of 5 divided by 5. So first term divided by the denominator, second term divided by the denominator. But notice though, you can go further with this. Negative 5 divided by 5 is negative 1. So you'd have negative 1 plus or minus 2 square root of 5 divided by 5, right? Divided by 5. Okay, and so those are different ways rather, of writing the answers. Notice though, my solutions, see the 4 square root of 5 is an irrational number, so you get irrational solutions. Irrational solutions here, okay? All right, now let's look at number 5. So in number 5, let's do one more. In number 5, we have this. All right, let's try this one. So we have x times x plus 6 plus 4 equals 0. All right, so this is written differently than the others. So in the others, you actually saw 3 terms, didn't you? You saw a squared term, you saw a constant term, and you saw a first degree term, and you saw a constant term. Here you don't see that. So what you got to do first is you have to distribute that x first. So I get x times x is x squared, x times 6 is 6x, and then plus 4 equals 0. And now you have this quadratic equation. Now this is quadratic, but this is written in a better way. All right. And so now you can determine what a, b, and c are. So a is 1. So remember, you have 0 on this side. B is 6, and C is 4. And it's just a matter of you taking these values and substituting it into the quadratic formula. So I get x equal the opposite of b, so I get negative 6, plus or minus the square root of 6 squared, b squared, 6 squared, minus 4 times a, which is 1, times c, which is 4, all divided by 2 times 1, right? And so I get negative 6 plus or minus the square root of 6 times 6 is 36. A negative times a positive is a negative, and then that's going to be 4 times 1 times 4 is 16, all divided by 2. So I get negative 6 plus or minus the square root of 36 minus 16 is 20, all divided by 2. All right, now notice the 20 is not a perfect square, so I'm going to end up with 2. I'm going to end up with my solutions being irrational. So I'm going to end up with irrational solutions. But notice also I can simplify the square root of 20 because 4 is the largest perfect square that goes into 20. So you want to simplify this as much as possible. So I get the square root of 4 times the square root of 5, and the square root of 4 is 2, so you get 2 square root of 5. So it's going to go here. So negative 6 plus or minus 2 square root of 5 divided by 2. Now, just as before, which I can show you, watch, just as before, see negative 6, 2, and 2 all divisible by 2, right? So negative 6 divided by 2 is a negative 3, 2 divided by 2 is 1, 2 divided by 2 is 1. And the fact that I have a 1 in the denominator, so that it's a numerator divided by 1, right? So it's just a numerator. So the answer is just negative 3 plus or minus the square root of 5. And that's it. All right, so those are your solutions. You get irrational solutions. So that's the number 5. Let's actually do one more. We have time for one more. So let's do one more. So this is number 6. All right, number 6. Let's suppose we had, let's do this one. So let's see what this is. We have 5n squared plus 4n minus 4 equals 0. So this is already in standard form. I have that 0 on that side. And so A is 5, B is 4, C is negative 4, right? And so we're going to take these values for A, B, and C. Again, make sure you're writing the signs correct. Double check, positive, positive, negative. Okay, so we look good. And so you can substitute those into the formula. And so, okay, so we get n equals, my variable is n, so we get n equals the opposite of b. So b is 4. The opposite of 4 is a negative 4. Plus or minus the square root of b, which is 4 squared, minus 4 times a is 5, times c, which is a negative 4. All divided by 2 times a, and a is 5. All right, and so let's simplify the radicand. So I get negative 4 plus or minus the square root of 4 squared, 16. Okay, negative times a negative is a positive. 4 times 5 is 20, right? And then 20 times 4, if you need to use your calculator, 20 times 4 is 80, right? All divided by 10. And then 16 plus 80 gives us 96 divided by 10. All right, so let's look at that square root of 96. So 96 is not a perfect square, so we end up with irrational solutions. All right, but let's see if I can simplify the square root of 96. So let's look at 4. Let's see if 4 will go into 96, if 96 is divisible by 4. And it is, okay? So 4 times 24 is 96, but look at that 24. What, is there another perfect square that goes into 24? Yeah, 4, right? 4 times 6 is 24. So that 4 times this other 4 gives us 16. So I'm going to write this as a square root of 16 times the square root of, and then 96 divided by 16 equals 6. All right? And the square root of 16 is 4, so that becomes 4 square root of 6. So that goes here. So I get negative 4 plus or minus 4 square root of 6 divided by 10. Now, I can simplify further. Because negative 4, 4, and 10 are all divisible by 2. So this becomes negative 4 divided by 2 is negative 2, plus or minus 4 divided by 2 is 2, and then 10 divided by 2 is 5. And that's it. There's your answer. Okay. Now, if you want to write this in two separate solutions, you can. You would say negative 2 plus 2 square root of 6 divided by 5. Negative 2 minus 2 square root of 6 all divided by 5. Make sure you're careful. Make sure there's no confusion how you're writing this, that negatives with this 2. Don't put that negative out in front, too far out in front to where I'm not sure if you're saying that the negatives with the fraction or the negatives with the 2. So be careful how you write these signs. Now you could also write this as, you see how I wrote this as one fraction, numerator, denominator? You can write this as two separate fractions. So you could say negative 2/5 plus or minus 2 square root of 6 divided by 5. So there's different ways of writing your solutions. All right, so that is some problems on solving quadratic equations using the quadratic formula.